Hello, everybody. This is an app that we are working on as a part of a companion to a paper that we're submitting to quality engineering. The paper is titled, What Should Quality Engineers Know About Generative AI? What this app does is we pull quality engineering related papers on ArXiv. We have a GitHub action that essentially goes daily at 10 a.m. UTC to pull new papers that have to do with control charts, experimental design, or reliability. Once we pull these papers, we use Elmer, which is an app, which is a library in R that allows us to use OpenAI to essentially send these papers to the OpenAI API, and we generate summaries from these papers. So just to show you kind of an example, this is an example that focuses on control charts. So we use the word control chart either in the title or in the abstract. And using that phrase, we're able to use the ArXiv package in R to search for archive papers, and then we download the PDFs from these, and then we process them as part of our analysis. So using the search term, there is 145 total papers that relate to process monitoring in ArXiv that we were able to find. These were between 2008 and 2026. Most of the common charts were on univariate charts, and then we're labeling the most common application to be more kind of theory driven type analysis. This is kind of the publication trend over time. So we can see, for example, in 2025, there were 21 such papers. And then in 2026, there are 2 such papers. You could kind of look at summary statistics on the field, and this will automatically be populated. For a specific paper, you can see in the overview tab, we're arranging them in the descending order by the most recent papers. You can click on the paper, it will open the PDF. You can kind of look at it. And then you can also, for example, if I look at another paper, I can kind of click on that third paper and I can see kind of the AI summary that we generated, some of the key results and some of the key equations in the paper. Let's say I'm interested in this paper on distribution-free process monitoring with conformal prediction. And then let me also say that I'm interested in, let's just pick the next paper as an example, the chart anchor, chart grounding with structural semantic fidelity. So these are 2 papers that I bookmarked, and we can kind of go back and talk about what that means. And then from the timeline, we can look at kind of publications by year. We can also see how certain topics evolve over time. So whether it's chart family or statistical method or application domain. And these categories are automatically populated. So they're going to be different for each of the 3 fields that we have. And then you can kind of do topic analytics. So you can kind of filter the data to look at different visualizations for these. So this is just a simple EDA on our field. So for example, we can see that there are more phase 2 papers than phase 1 papers. There are some papers that seem to have talked about both, not necessarily that did both, but this is something we can see. And then we can see that outside of the theory simulation only type papers, manufacturing seems to be kind of the most common application for statistical process monitoring. And then on the author analytics, we can see that Biagio and Antonio are the 2 most prolific authors on ArXiv. So each of them have 6 papers. And then they're followed by Sven Noss, who has 5 papers, as well as Fabio Centofanti, who has 5 papers, and Mossen as well. So this is something that we can see. We can then, from the authors who have the most papers, you can kind of see what papers they have. So here are the 6 papers that Antonio has. If I go to Fabio, for example, or Sven, I can see here are the 5 papers that Sven has. And if I were to click on one of the papers, I can kind of open the paper and look at it. So this is something that we want to highlight. And then in the deep dive, you see the summary kind of piece that we've talked about, but you can also talk to the AI about a specific paper. So like, for example, I can search for Ines, and you can see that one of the things that we have that we're going to try to work on is if an author used different names, we can try to merge their data. This is something that would require knowledge of specific authors. So for Ines, obviously, we can do that. But for some authors, we might not be sure if that's the same person or not, especially if they changed an institution, for example. So let's say we're just going to focus on the 4 papers that Ines had as Ines Maria Zwetsloot. And then we can pick a paper, and I'm just going to pick this paper as an example. And I can say, I can use one of these like built-in questions. These are questions that are still going to be sent to an AI, but here we're using GPT-5 Mini to kind of control costs. And I can say, what are some limitations of this paper? And then once I have that, it's going to essentially take the PDF of that paper, pass it to the Open AI API. So Elmer allows us to essentially upload a PDF via a link. And then from here, you can see kind of now that the model is kind of taking into account this information, and then it's going to stream the response as it's being produced. So this is something that you can kind of see from the answer. So here's some of what GPT-5 Mini thinks are some limitations on this, and you can kind of chat, and it will maintain history. You can do kind of multi-turn conversations in this window. And then in your library, if you had several papers, you can, for example, export the BibTeX for them. So this will allow us to open the BibTeX for these papers. So you can kind of see that here is the bib file, here is the title for the first paper, here is the title for the second paper, and here is some of their information. And we do tell you that this was essentially downloaded from our app at that date, and here are the total number of papers that you export. So we think that this is a nice feature. And then if you have a collection of papers that are coherent, maybe this might not be the best example, you can also chat with the collection. So we'll upload both papers and provide a summary of the contributions for both papers. So this is something that you can see. And then as this is populating, we can also go and talk about how we're getting the data. So this is our GitHub repository, and through GitHub Actions, we have a daily refresh and a weekly refresh. The daily refresh runs around 5 a.m. Eastern, which is 10 a.m. UTC. And you can see that some of these are scheduled. So these happen automatically every day. The last run that I have was, I'm using the Remv now package, which would allow me to cache the libraries. And that allowed us to reduce the runtime from 12 minutes to 3 minutes. So this is something that we're just doing it for efficiency purposes. But again, based on kind of the summary of the contributions for both papers, you can see here is the contribution of the first paper, and then here is the contribution of the second paper. We can also ask questions that have to do with synthesizing that information. So this is kind of our quick overview. And then from here, I'm just going to make one highlight that for the design papers, for example, we are using the following search terms. So experimental design, designed experiment, design of experiment, response surface, or super saturated design. And we're only focusing on the titles because we assumed that some of the kind of statistical, industrial statistics kind of researchers and practitioners might not be interested in papers that might have done experimental design, let's say for education or for some other field where it's a purely applied paper. So that was a way of reducing kind of the number of papers that we have to process. We already have kind of analyzed over 1,000 papers across the 3 fields. So this is something that we've done in the DOE field, and then we've done a similar thing in reliability, but we've also added some categories on ArXiv to also reduce the search. And you can see that our data is current as of today, and the latest paper that we included was actually from yesterday. So this is something that we've done just to manage the cost. We do acknowledge that essentially we cannot get every single paper that is written, but across the 3 fields we have already kind of analyzed, and we make it available for you to just download with a click of a button these 1,400, like each of the 1,400 different papers. Hopefully this is helpful, and we look forward for your feedback.